to Hutchins 360 STEM. We have myself, Mrs. Hutchins, your favorite science teacher, and Jordan. And today we are going to do a catalyst experiment called making elephant toothpaste. So let's get started. Are you guys ready?
Yep.
Are you ready, Jordan?
I am ready.
Okay, only do this if your parent or an adult is supervising your experiment. We want to always make sure that we have what first, Jordan?
Goggles.
Goggles. Okay, so we're going to put on our goggles. Now, normally, both of us would have a lab coat on. Jordan will be in full lab gear next week. So we're going to make sure that she's nowhere near the chemicals because we don't want anything to spill on her, right?
Right.
Right. So here we go. First, we're going to go over some of the tools and lab equipment that we're using today. We are using a 2,000 milliliter graduated cylinder. Have you ever seen one of these before?
Mm-hmm.
You have? Where have you seen this before?
In my office and
In your office. You have an office?
sometimes in the store.
And sometimes in the store. Okay. So we use graduated cylinders in a lab to measure the volume of liquids. But today we're going to use these graduated cylinders to do our chemical reaction. We're going to put all the ingredients for the chemical reaction to take place in these graduated cylinders. So we have a 2,000 milliliter graduated cylinder, which is equivalent to 2 liters. And we have two 1,000 milliliter graduated cylinders, which is equivalent to 1 liter. There are 1,000 milliliters in a liter. Okay, Jordan, let's tell them which materials they're going to need in order to do today's reaction. This is Dawn dishwashing detergent, right? We use this to wash the dishes.
Yeah.
And in this brown bottle, we have a chemical substance that you probably have in your house. Hydrogen peroxide. Can you say hydrogen peroxide?
Hydrogen peroxide.
Yes. And the chemical formula for hydrogen peroxide is H2O2. H is for, do you remember from last week's experiment? Hydrogen.
Hydrogen.
And O stands for oxygen. That is right. So this chemical is stored in a brown bottle. It is opaque, meaning we can't see through it. It's not transparent. It's not translucent. We can't see through it. And the reason that it has to be stored in a dark container is because it's highly reactive. Your mom and dad have probably used this on your skin if you ever got a cut before. Hydrogen peroxide helps heal cuts faster. Also have water for today's experiment. And we have, what is this?
Yeast.
This is yeast, yes. What do you know yeast to be used for? Baking bread.
Baking bread.
That's right. We use yeast in cooking. This is nutritional yeast. It's dry. Today, we're doing a catalyst experiment. I'm going to hold this up closer for you guys to see what I have here. This is yeast. Hi, everyone. Okay, so we're using yeast. This is a catalyst-based reaction that we're going to do today, which is commonly referred to as making elephant toothpaste. The yeast is the catalyst. Catalysts are substances that speed up chemical reactions without being used up. So the yeast will remain left behind at the end of the reaction. So let's get started. First, Jordan and we're going to mix the yeast with a little bit of water. So that's going to be the first part of our reaction. You want to make sure that you do this part first so that you can get your yeast acclimated with the water. I'm going to use quite a bit of yeast here. I have a tablespoon from the kitchen, right? A tablespoon.
Yeah, tablespoon.
And we're going to use about 3 tablespoons of yeast today. We want a lot of catalyst because we want a nice big reaction. Now, we probably won't get a super explosive reaction because today we're using a 3% hydrogen peroxide solution. when you look at television or other YouTube channels and you see these big explosive elephant toothpaste demos, they are probably using a less diluted form of hydrogen peroxide. They're probably using about 12%. But for today, we're using a 3%. It's safer. I mean, after all, Jordan is only, how old are you?
I am 6 years old.
She is 6 years old.
Almost about to be 7.
Almost about to be 7, that's right. So far, we placed about 4 tablespoons of yeast into this bowl. And Jordan is going to help me pour the water into the bowl. We're not going to pour it all. We're going to pour just enough to cover up the yeast. Go ahead, Jordan. And that's good. And we're going to go ahead and mix the yeast. You want to do this before you actually start the experiment so that you can get the yeast all mixed up here. So we're just going to mix it. We're not going to mix it close to our faces. You don't want to taste this. You don't want to put it on your skin or anything like that. So we're just going to mix it. So Jordan, I'm going to have you just keep mixing it real quick for me. Very gentle, very easy. While Jordan is mixing, very gentle, Jordan. You don't want to spill it, okay? So very gentle. And the yeast kind of starts to clump up a little bit. I'm going to come closer and show you. So as I'm mixing it, you can see it's kind of clumping up a little bit. So that means I probably need to add a little bit more water to the mixture. So we're going to do that now. A little bit more water to the mixture, that's right. Ah, okay. All right, Jordan, I'm not going to have you mix anymore, okay? All right, Jordan, let's step back so that we can show the next ingredients. So we're going to go ahead and pour some of the Dawn dishwashing detergent into our graduated cylinders. Do you remember what size this graduated cylinder is? 2,000 milliliters. That is correct. So I'm going to pour, and I'm not measuring this, guys. I'm just having fun here. Pouring the dish detergent into the graduated cylinder.
And I'm going to hold it.
And Jordan is holding it. You want to get a nice little bit in there? Kids, before trying this at home, please make sure that you ask your parents permission. They're serious about their Dawn dishwashing detergent, okay? All right, and we're going to pour some more in the other 2 graduated cylinders, the 1,000 milliliter graduated cylinders. Okay.
And then the other.
Then the 3rd one. So exciting. Okay. Let's pour a little bit more in the big one, Jordan. Pour a little bit more. All right. And if you really want to spice things up and make this interesting, you can add food coloring. So we are going to add some food coloring. Now these days, when you go to the grocery store, a lot of the food coloring is sold as a gel, and gels will work. So we have a lot of nice little colors here. I'm going to let Jordan choose the colors. All right, so we have orange, we have neon pink, neon green, and neon purple. Neon purple?
I want neon purple.
You want neon purple? Okay, so we're going to use these colors. Well, not all of them, because we only have 3 graduated cylinders. So what are the 2 other colors you'd like to use?
Neon pink.
Of course,
Because
pink.
Because
And what
these
else?
are my favorite colors.
These are your favorite colors, and what else would you like to use? One more. Green. All right. So the next thing we need to do is add the colors to the beaker. Which color do you want to go in the, not the beaker, the graduated cylinder. Which color do you want to go in the graduated cylinder?
Pink.
The large one. Pink. Okay, so our most explosive reaction is going to be the pink reaction. Okay, if I could just get this open. Here we go. Okay. It's not going to explode. And you want to pour it right down the middle. Don't want to get any on the sides of the graduated cylinder.
Okay.
And Jordan, I'm going to let you do the purple, come off over here on the side so everyone can see what we're doing. And I am going to do the green. So put the purple in that one. Go down the middle and just squeeze. Very good. I don't know why these things are so hard to open. There we go. Okay. I'm going to put green in these.
I'm going to put purple.
All right. All right, that's good. Okay. The next thing that we want to add is our hydrogen peroxide. And remember, be very safe when doing this one. So I won't let Jordan help me to pour this one. I'm going to pour this. So kids, if you're at home and you're doing this experiment, please have a parent help you pour the hydrogen peroxide. Nope, not yet. The catalyst is the yeast, remember? Yeah. All right. So we're going to pour some hydrogen peroxide in each of these. And no, I know guys, you're probably wondering, how much? I haven't pre-measured this. Now, if I was in a classroom setting, I might measure it. But because I'm at my house, you know, we're going to have some fun here. Okay. Now, Jordan, we are going to do the best part. We are going to add the catalyst, Jordan. Are you ready?
I'm ready.
Oh my gosh, Jordan. This is so exciting. Okay, gonna mix this yeast a little bit more here before we add it. It's looking really kind of crazy. Okay, I don't know if you can still see it here. Okay, this is our yeast. Okay, the next thing we're gonna do, and also parents, you want your children to step back from the experiment. This is an exothermic reaction. Now, for some of you, that might be a new vocabulary word. Exothermic chemical reactions are those reactions that release a lot of heat energy. Because of the interaction between the water molecules and the hydrogen peroxide molecules, this catalyst called yeast is going to cause the reaction between the ingredients to happen very rapidly. And because it's happening so rapidly, it produces a lot of kinetic energy. And if you know anything about kinetic energy and temperature, the faster the particles are moving, the higher the kinetic energy. And when we have fast-moving particles, high kinetic energy, we produce a lot of heat energy. So that is a safety concern for this experiment. You want to make sure that your child is standing all the way back from the experiment, okay? All right, let's go. All right, Jordan, step back.
I'm stepping back. Step back.
And we're going to go ahead and add the catalyst. All right. And we're going to go ahead and add... Jordan,
Wow.
what's happening?
It's
Wow.
Whoa, that's so amazing. Wow.
Oh my gosh.
Wow, that's tough.
What is this? What's happening here?
That's tough.
That's big tough? Oh my gosh.
Wow.
So it didn't happen as explosively as we thought it would. So we're going to add a little bit more hydrogen peroxide to get this baby going. And if you notice, I have the graduated cylinders inside of bowls to catch some of the mess. Because right now we have a lot of, come here Jordan, come see. We have a lot of oxygen gas bubbles forming. And because of that, we get this soapy foam. And if you really want to help things along, I'll use one of my nifty, thrifty glass stirrers. Okay, let's kind of mix it up here. Get this baby going a little bit so you can see the colors. And don't worry, if your experiment doesn't work out good the first time, that's the beauty of science. You get to do it again and again and again.
Mommy,
Yes?
it didn't make an explode. It's just,
And why do you think that is? Why do you think that happened?
because maybe we didn't.
Hmm.
Maybe
hydrogen peroxide.
Or any more, or not enough of the yeast.
Okay, the yeast.
The yeast.
Oh, so Jordan said we may have needed a little bit more yeast. So let's talk to the people about what they just witnessed here. So it slid down a little bit. Yes, that's true. But we probably should have mixed it before we added the catalyst to get that color going really good. And when you use a stronger concentration of hydrogen peroxide, you get a bigger reaction. But I didn't want to do that today because my helper is so young. But if you are a chemistry teacher in school teaching high schoolers, you may want to start with a 6% hydrogen peroxide and then graduate up to a 12% hydrogen peroxide. So we hope that you enjoyed our experiment today, and we are ready to take questions.
So, what questions do you need to be answered?
Oh, the beauty supply store sells the highly concentrated hydrogen peroxide. Thank you, Hassan.
Thank you.
Okay.
What else questions do we got?
Do we have? All right. So we thank you so much for tuning in today, and we will be back with more experiments for you. Next week, we're going to focus on some physics. Bye, everyone. Thank you for joining us.
It's so hot out here.
'Cause it's summertime, Jordan. All right, we're back. We're going to do a more explosive version of the elephant toothpaste demo. Here goes. Pouring the catalyst in with the hydrogen peroxide, the food coloring, and the dish detergent.
Let's see what happens.
Oh my goodness, do you see it? If elephants brush their teeth, do you think they would like this one? Is this good toothpaste? We're gonna pour some more of the catalyst, the yeast. All right. And there you have it, elephant toothpaste.